Let's start with today's featured paper, Efficient Hallucination Detection for LLMs Using Uncertainty-Aware Attention Heads, by Artem Vazantsev and Artem Shulmanov from Mohammed bin Zayed University of Artificial Intelligence, MBZUAI. This paper was selected because it introduces an unsupervised and efficient framework for detecting hallucinations in large language models, directly addressing the most critical barrier to their trustworthiness and widespread adoption. Here's a full breakdown. Contribution 1. Unsupervised Hallucination Detection. Recurrent Attention-Based Uncertainty Quantification, RUQ, was developed as an unsupervised and efficient framework for identifying LLM hallucinations. The method leverages the observation that uncertainty-aware attention heads reduce their focus on preceding tokens when incorrect information is generated, combining these patterns with token-level confidence in a recurrent scheme. This provides a lightweight, plug-and-play solution for real-time hallucination detection in white-box LLMs, requiring neither labeled data nor extensive parameter tuning. Contribution 2. Attention-Based Uncertainty Mechanism. A novel mechanism for uncertainty quantification was discovered, based on transformer attention behavior, where specific uncertainty-aware attention heads reduce focus on preceding tokens during incorrect information generation. RAUQ automatically detects these heads and integrates their activation patterns with token-level confidence measures via a recurrent scheme to derive a sequence-level uncertainty estimate. This internal model mechanism enables unsupervised uncertainty quantification in a single forward pass, significantly improving efficiency over prior computationally intensive or supervised methods. Contribution 3. State-of-the-art performance and efficiency. RAUQ consistently outperforms state-of-the-art UQ baselines across 12 datasets spanning question answering, summarization, and translation on 9 different LLMs. The method achieves this by producing a sequence-level uncertainty estimate from attention head activation patterns and token-level confidence in a recurrent scheme during a single forward pass. It incurs minimal overhead, requiring less than 1% additional computation, establishing it as a highly efficient and practical solution for real-time hallucination detection. That was our featured paper. Today, ArXiv received 896 new computer science papers across 55 subfields. Let's look at the research landscape before we continue with the remaining papers. Today's AI research landscape is buzzing with efforts to understand LLM behavior and build trust in human-AI collaboration, alongside fascinating work modeling complex physical systems. Now let's see which papers stood out. Prepare for a shocker. A promising new memory tech is fundamentally flawed, corrupting computations. Plus, LLMs are now designing algorithms that outperform human experts. Now let's explore each of today's trends in detail, starting with number 1. Trend 1 of 10, Speech and Language Model Analysis. This trend analyzes various speech and language models, exploring their architectures, parameters, and applications, often for cross-lingual or dialectal tasks. This cluster covers 19 papers. Representative work includes Why Swave May Not Be All You Need, a concept evolution retrospective on complex valued recurrent language models, LLM parameters for math across languages, shared or separate, and Montreal Forced Aligner and the State of Speech-to-Text Alignment in 2026. Trend 2 of 10, LLM Human-like Behavior and Bias. Analyzing LLM's human-like cognition, social behaviors, and inherent biases, assessing their emulation and implications. This cluster covers 104 papers. Representative work includes From Memorization to Creation, evaluating the cognitive depth of LLM-generated educational questions, examining human-like behaviors in LLMs, a multidimensional analysis of model behaviors, user factors, and system prompts, and when prompts mislead, textual dominance and diagnostic bias in MLLMs. Trend 3 of 10, Modeling Complex Physical System Dynamics. This trend explores advanced computational and AI methods to model, understand, and predict the dynamics of complex physical and biological systems. This cluster covers 111 papers. Representative work includes a Physical Adaptive Material Motor Unit Neural Network, a hygromorph composite material machine, joint discovery of graph structure and dynamics in stochastic interacting particle systems, and a generalized transform framework for a nonlinear model of cancer dynamics. Trend 4 of 10, Autonomous Robotics and Manipulation Learning. This trend explores learning-based methods for autonomous robotic systems, focusing on manipulation, navigation, and intelligent interaction with environments. This cluster covers 117 papers. Representative work includes NAVI-Orbital, first in-orbit demonstration of a zero-shot vision language model for autonomous Earth observation, recover, discover, plan, learning skills and concepts from robot failures, and Guava, an effective and universal harness for embodied manipulation. Trend 5 of 10, AI system enhancement and optimization, focuses on improving AI model performance, efficiency, interaction, and specific functionalities through various optimization techniques. This cluster covers 64 papers. Representative work includes dynamic in-group persona generation for enhancing human-AI rapport, immersion, examining the impact of audio parameters on emotional responses and immersion in film, and continuous audio thinking for large audio language models. Trend 6 of 10, vision model robustness and security. This trend explores methods to enhance the reliability, security, and resilience of vision models against various challenges and adversarial attacks. This cluster covers 76 papers. Representative work includes Artemis, anatomy-resolved intervention for eliminating multimodal neuroimage confounders, budget-aware adaptive adversarial patches for black box object detection, and regime VGT, layer-wise spatially preserving redundancy removal for visual geometry grounded transformer. Trend 7 of 10, graph neural networks and attention. This trend explores integrating graph neural networks with attention mechanisms for enhanced data processing and understanding across diverse applications. This cluster covers 75 papers. Representative work includes fluid views, adaptive drag-and-drop token filters for heterogeneous multi-view visual analytics, Hydra, lossless hypergraph summarization via co-clustering, and Gaussian mixture attention, linear time sequence mixing via probabilistic latent routing. Trend 8 of 10, human-AI collaboration and trust, exploring how humans and AI effectively collaborate, fostering trust, and managing complex interactions across diverse applications. This cluster covers 116 papers. Representative work includes ATIM, an ACTR-based task interface model for predicting operator action time in digital nuclear control rooms, human-machine bidirectional trust-aware analysis and design for human-led truck platooning, and caring without feeling, effective dynamics as the control layer of human-AI agent collaboration. Trend 9 of 10, graph and geometric data structures, exploring the design, analysis, and application of graph and geometric data structures for diverse problems. This cluster covers 104 papers. Representative work includes graph instance landscapes, when structural similarity does not reflect shortest path performance, a stochastic ISCS Markov model for fake news propagation, and denoising distances in metric measure spaces. Trend 10 of 10, refining training for robust models, developing sophisticated training methodologies and data refinement strategies to build more robust, reliable, and consistent AI models. This cluster covers 110 papers. Representative work includes breaking the solver bottleneck, training task generators at the learnable frontier, Drift, refining instruction data via on-policy data attribution, and Trident, breaking the hybrid safety physics coupling for provably safe multi-agent reinforcement learning. That's the full research landscape for today. Remember, our number 1 paper, Efficient Hallucination Detection for LLMs Using Uncertainty-Aware, was already covered at the top. Now let's continue with papers 2 through 10, one by one. Up next, our second paper out of 10, NAVI-Orbital, first in-orbit demonstration of a zero-shot vision language model for autonomous Earth observation by Juan M., Delphi Victoria, and Andrew W. Herson from Jet Propulsion Laboratory, California Institute of Technology. This paper was selected because it presents the first in-orbit demonstration of a zero-shot vision language model performing autonomous multimodal inference on a low Earth orbit spacecraft, marking a significant milestone in deploying advanced AI to extreme, real-world environments and addressing critical data bottlenecks. Let's break down its key contributions. Contribution 1. First in-orbit VLM demonstration. NAVI-Orbital achieved the first in-orbit demonstration of a zero-shot vision language model for autonomous Earth observation on April 16, 2026. A local vision language model, Gemma 3, performs multimodal inference entirely on board, classifying scenes, generating text descriptions, and responding to natural language dialogue, orchestrated by a Langgraph-based state machine. This overcomes the widening gap between data generation and actionable intelligence by enabling real-time insights from space and addressing downlink bandwidth limitations through semantic compression. Contribution 2. High accuracy onboard inference. NAVI-Orbital demonstrated high accuracy in onboard vision language model inference, achieving 88.16% accuracy on the 7,960 image curated AID benchmark. The system uses a local vision language model, Gemma 3, on satellite-class edge computers with hardware-accelerated GPU inference to process newly acquired, unseen Earth imagery without fine-tuning. This proves the feasibility of deploying foundation models on resource-constrained satellite hardware, moving beyond specialist detectors that require retraining for new phenomenologies. Up next, our third paper out of 10, ROBOSHACKLES, a safety dataset for human injury prevention in embodied foundation models by Zhou and Inxing Xue. This paper was selected because it addresses the critical and ethically challenging problem of human injury prevention in embodied foundation models by introducing a novel safety dataset construction pipeline, which is foundational for advancing AI safety research where real-world data collection is impossible. Let's break down its key contributions. Contribution 1. ROBOSHACKLES Safety Dataset Creation. The ROBOSHACKLES dataset, comprising 10,000 robotic video clips, was constructed from real DROID observations to address human injury prevention in embodied foundation models, EFMs. This dataset spans 2 direct harm and 4 indirect harm categories, generated through a pipeline involving scene understanding, hazard-aware image editing, temporal prompt generation, and 2.7 based single-pass rollout synthesis. ROBOSHACKLES provides a scalable benchmark and training resource for refusal learning and hazard anticipation, overcoming the ethical and safety barriers of real-world data collection for robot-human interaction. Contribution 2. Novel Safety Data Pipeline. A novel safety-critical data construction pipeline was developed to generate data for human injury prevention in embodied foundation models, EFMs. The pipeline initiates with real DROID observations, then applies scene understanding, hazard-aware image editing, temporal prompt generation for scene evolution, and single-pass rollout synthesis using 2.7 to create realistic hazardous scenarios. This methodology enables the creation of safety-critical data that is otherwise unethical or unsafe to collect in physical environments, directly supporting responsible AI development in robotics. Up next, our fourth paper out of 10, Steerable Cultural Preference Optimization of Reward Models by Minsik O. and Ekaterina Shatova from Stanford University. This paper was selected because it introduces a novel approach to steerable cultural preference optimization, directly addressing the critical and pressing problem of making large language models fair and acceptable across diverse global communities. Let's break down its key contributions. Contribution 1. Steerable Cultural Preference Optimization. A novel reward model training algorithm, SCPO, Steerable Cultural Preference Optimization, was developed to incorporate diverse cultural preferences in a balanced manner. SCPO builds steerable reward models specific to a country's point of view by employing a weighting method that mitigates excessive bias during training. This advances LLM alignment beyond predicting a unified preference, enabling models to accurately represent and be steered towards the preferences of diverse subcommunities. Contribution 2. Enhanced Minority Reward Model Performance. The SCPO algorithm significantly enhances the performance of minority reward models, achieving improvements of up to 7 points over baseline models. These gains were observed across the PRISM and Global Opinion QA datasets in 7 countries. This directly addresses the problem of LLMs reflecting opinions from privileged populations or overrepresenting Western countries, making LLM alignment more equitable and effective for global subcommunities. Up next, our fifth paper out of 10, GateMem, Benchmarking Memory Governance in Multi-Principal Shared Memory Agents by Zhiren and Shuiqing Yan from School of Artificial Intelligence, Jilin University. This paper was selected because it introduces a novel and critical benchmark, GateMem, which addresses the previously understudied but highly pressing problem of memory governance in multi-principal shared memory LLM agents, thereby laying foundational groundwork for the safe and reliable deployment of AI in complex, real-world environments. Let's break down its key contributions. Contribution 1. GateMem Shared Memory Benchmark. GateMem is introduced as a new benchmark for multi-principal shared memory LLM agents, evaluating memory quality beyond recall to include governance, privacy, and security in shared contexts. It jointly assesses utility for legitimate long-horizon requests, access control across contextual authorization boundaries, and agent-facing active forgetting after explicit deletion requests using long-form multi-party episodes and leak target annotations. This benchmark addresses a critical, unaddressed challenge for deploying AI agents in sensitive, multi-user environments like hospitals and workplaces, where prior benchmarks focused on single-user maximum recall. Contribution 2. Critical memory governance gap identified. A critical, unaddressed challenge was identified in evaluating LLM agent memory for multi-principal shared environments, where memory quality requires governance, as well as recall. Existing memory benchmarks largely assume single-user settings and prioritize maximum recall, treating memory as a private cache, which is insufficient for common memory pools accessed by multiple principals. This gap means current evaluations fail to prepare agents for sensitive institutional deployments, as high recall without strict governance becomes a security vulnerability in such contexts. Up next, our 6th paper out of 10, PuDGhost. Experimental analysis of computation result corruption in processing-using-DRAM operations on real DRAM chips and implications for future systems by Daichi Takuda and Onur Mutlu from the University of Tokyo. This paper was selected because it presents the first experimental analysis on real DRAM chips, revealing critical computation result corruption in processing-using-DRAM (PUD) operations, which fundamentally challenges a promising paradigm for future computing systems. Let's break down its key contributions. Contribution 1. PuDGhost Interference Characterization. The paper reveals PuDGhost, an interference phenomenon causing erroneous results in processing-using-DRAM (PUD) operations, quantifying its impact from non-activated rows up to 10% and concurrently computing columns up to 48% for random inputs. PuDGhost occurs when a CMRA, simultaneous multiple row activation, operation in a column is corrupted by data in physically adjacent non-activated DRAM rows or data in other columns computing concurrently. This is the first extensive characterization of such interference using 96 real DDR4 DRAM chips, highlighting a critical, previously uninvestigated limitation for future memory-centric architectures and PUD systems. Contribution 2. Robust column screening. A robust column screening technique is proposed and evaluated to counter PuDGhost by identifying unreliable columns. This mechanism reduces the risk of using interference-prone columns by screening them out, ensuring only reliable columns participate in PUD operations. This solution, evaluated on real DDR4 DRAM chips, significantly improves PUD computation accuracy by preventing errors from unreliable columns. Up next, our 7th paper out of 10, MORTAR, Multi-Turn Metamorphic Testing for LLM-Based Dialogue Systems by Guoxiang, Aaron, Gua, and Songyu Chun from Monash University. This paper was selected because it introduces a novel metamorphic testing framework, MORTAR, that effectively addresses the critical and long-standing Oracle problem in quality assurance for multi-turn LLM-based dialogue systems, significantly advancing the reliability and trustworthiness of these widely deployed AI applications. Let's break down its key contributions. Contribution 1. Mitigating multi-turn Oracle problem. MORTAR proposes a metamorphic multi-turn dialogue testing approach that effectively mitigates the test Oracle problem in LLM-based dialogue systems. It formalizes multi-turn testing and automates the generation of question-answer dialogue test cases using dialogue-level perturbations and metamorphic relations, MRs. This approach enables fully automated quality assurance for complex dialogue flows, overcoming the challenge of manual Oracle creation and LLM judge reliance. Contribution 2. Automated multi-turn test generation. MORTAR automates the generation of question-answer dialogue test cases for multi-turn interactions in LLM-based systems. It leverages multiple dialogue-level perturbations and an automated MR matching mechanism to systematically derive varied test scenarios from an original dialogue. This mechanism provides flexibility and efficiency in testing, significantly reducing the effort required for test case creation compared to prior single-turn methods. Up next, our 8th paper out of 10, Outrunning LLM Cutoffs, a live kernel crash resolution benchmark for all by Qinxi Huang and Baishaki Ray from Columbia University. This paper introduces a crucial live benchmark that addresses the fundamental problem of evaluating LLMs in dynamic, evolving system environments, thereby enabling robust and reliable application of AI to critical software engineering challenges like kernel crash resolution. Let's break down its key contributions. Contribution 1. LiveKBench Dynamic Evaluation Framework. LiveKBench is introduced as a novel live benchmark for kernel crash resolution, designed to continuously evaluate LLM-based agents. Functions as a self-evolving evaluation framework that scrapes and assesses agents on freshly discovered kernel bugs as they emerge. approach overcomes the limitations of static benchmarks and data contamination by reflecting the evolving nature of the Linux kernel, providing a more realistic assessment of agent capabilities. Contribution 2. KNV Standardized Execution Environment. KNV is presented as an agent-agnostic standardized environment for kernel crash resolution. Decouples agent workflows from heavyweight execution by handling kernel compilation, execution, and feedback in a consistent manner. Standardization enables fair and scalable comparison of diverse agent frameworks under identical conditions, improving the rigor and reproducibility of LLM agent evaluations. Up next, our 9th paper out of 10, LLM-Evolved Domain-Independent Heuristics for Symbolic AI Planning by Elliot Gestrin and Jendrik Seep from Linköping University. This paper was selected because it introduces a novel paradigm where large language models, through evolutionary search, can discover domain-independent heuristics for symbolic AI planning that surpass human-engineered state-of-the-art, fundamentally advancing automated algorithm design. Let's break down its key contributions. Contribution 1. LLM-Evolved Superior Domain-Independent Heuristics. The first LLM-generated domain-independent heuristics that exceed the hand-engineered state-of-the-art for symbolic AI planning were produced. An evolutionary search uses an LLM to mutate parent heuristics written in C++, storing candidates in a map-elites archive keyed on informedness and speed, with fitness blending coverage and solving time. The best evolved heuristic solves more tasks than the strongest baseline on unseen testing domains, demonstrating AI's ability to surpass human experts in fundamental algorithm design. Contribution 2. Comprehensive Heuristic Trade-off Benchmarking. A broad set of hand-engineered heuristics were benchmarked on their informedness speed trade-off, a comprehensive evaluation not previously conducted. This involved calculating fitness scores by blending coverage with solving time and storing candidates in a map-elites archive to systematically compare performance characteristics. This novel contextual framework reveals the Pareto frontier of the trade-off, offering a nuanced understanding of heuristic strengths and weaknesses. Up next, our 10th paper out of 10, Everywhere Valid Bounds on False Discovery Proportions in Conformal Inference by Ziyang Song and Emmanuel J. Candes from Stanford University. This paper was selected because it introduces everywhere valid bounds on false discovery proportions in conformal inference, representing a significant theoretical and practical advancement that provides stronger, more reliable statistical guarantees crucial for trustworthy AI and data science. Let's break down its key contributions. Contribution 1. Everywhere Valid FDP Bounds. Finite sample, distribution-free upper bounds on the false discovery proportion, FDP, are established, holding simultaneously over all possible rejection thresholds. This is achieved by constructing a high-probability envelope for the empirical distribution function of null conformal p-values by sampling from their joint distribution. This enables arbitrary post-hoc selection of the threshold without invalidating statistical guarantees, providing stronger assurances than prior methods controlling only expected FDP. Contribution 2. Modulatable envelope for tightness. A flexible framework allows practitioners to modulate the envelope's shape during the construction of the high-probability envelope. This modulation is applied to the empirical distribution function of null conformal p-values to tailor the bound. The ability to modulate the envelope produces tight bounds specifically in rejection regions of primary interest, leading to substantially less conservative results than existing approaches. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.